Good morning. I am V. Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about previous question papers. One of the question papers December 2024. In that, one of the question is characteristics of the embedded system and the quality attributes of the embedded system. That will be discussed. Characteristics. Every device has its own characteristics. Here, embedded system having certain type of characteristics. We will discuss. First one, application and domain specific. Means whatever the purpose I desired the embedded system, I can use that one for the further purpose. Suppose I designed the washing machine for washing the clothes. I can't use that washing machine to take the printouts or to play the music. Okay. So I designed the washing machine for washing the clothes only, not for playing the music or doing some other works. Take the printouts. Next, reactive means reaction with respect to changes in the real-time environment. The response should be changed. Suppose I am traveling in that car. While traveling, some objects come, some cows or buffaloes or somebody, persons, human beings, some vehicles comes in front of the vehicle. So, since they are coming, immediately the ABS needs to be activated. Anti-lock braking system means that ABS will control the vehicle movement within the fraction of seconds. Otherwise, my vehicle hit the object. So, embedded system should be reactive in nature. Means, with respect to changes in the real-time environment, the output should be changed. One more example. In the outside, the temperature changes. Suppose initially the room temperature is 27 degrees. After some time, the temperature, in the morning, the temperature is 27 degrees. As time is going on, at time 12 or 10 o'clock or 11 o'clock or 12 o'clock, the temperature may be increasing. Means 27 degrees to 30 degrees, 35 degrees, 40 degrees in summer. In summer, maybe 45 degrees. At that time, initially we are setting the temperature to the 20 degrees or 16 degrees or 18 degrees, some temperature. Even the temperature changes, if the AC cooling fan is not changing, means we are in the normal temperature, means 45 degrees temperature, like that. If that cooling fan valve is not changing, means. So what is the use? So, as temperature changes, that current temperature is comparing with the desired temperature based on the difference between current temperature and room temperature, current room temperature and desired temperature. The AC valve needs to be adjusted. If temperature is more means cooling fan's valve size is more. Otherwise, if temperature less means the valve size needs to be reduced. So valve size varying means corresponding cooling air is coming from this cooling tank will be changes. If valve is more means more cooling air is coming. Valve is small means less cooling air is coming. Like that. So finally it maintains constant desired room temperature. Okay, that is reactive in nature. Real time means they have some deadlines. Within that time, the vehicle movements should be controlled. Within that time, the airbags needs to be opened. Within that time, the leakage occur in the nuclear plants needs to be identified and controlled. Within that time, whatever the poisonous gases released in the industry that needs to be identified and needs to be controlled are taking the corresponding precautions within that time. That is within the time is deadline, within the second, within the fraction of seconds, within the minutes by the embedded systems. Next, operates in the harsh environment. Means, suppose I designed one embedded system like mobile phone. That mobile phone operating temperature is something 27 degrees like that in India. Suppose I am traveling to foreign countries because of my works or something tourism, tourist places like that. Their temperature may be minus 0 degrees or minus degrees. At that time also the mobile needs to be work. Like that I need to design the mobile phone. Otherwise, my mobile phone is working only during 20 degrees to 27 degrees means what is the use? That is, that mobile is purchased in the corresponding countries only, not in other countries. So my margin is less. Or in India also the temperature changes based on the weather conditions. Sometimes the temperature may be 16 degrees. In Kashmir like that, minus degrees. In Andhra Pradesh or Telangana, maybe some 27 degrees or 30 degrees. In summer cases, the temperature may be 45 degrees. So temperature is fluctuating. So if the temperature changes, again I am purchasing new mobile phone means, is it valid? No. So my mobile phone needs to be operated in most of the environment conditions. Like that, I need to design the embedded systems. Either it is working in high temperature mode, like oceans are 40 degrees, 50 degrees like that. Or it is also in minus degrees temperature also. Like that, I need to design the mobile phone. Or high pressure. Suppose I keep the mobile phone in my back pocket. So my weight is 100 kg, let us consider. So 100 kg weight is on the mobile phone. At that time also, if I get the call means my phone is ringing. Needs to be ringed. If the pressure is more, suppose I keep my mobile phone in the bag, my mobile phone size weight is something 150 kgs. Even 150 kgs, if I get the call means my mobile phone needs to be ringed. Otherwise, if it is not ringing means I have not purchased that mobile phone. So the designer may lose that margin. Or sometimes some of the embedded systems needs to be worked in industries. In the industries the temperature may be high temperature, maybe 100 degrees. At that time also the device needs to be worked, whatever the device I designed for that industry. According to that I need to design. So that is, my mobile phone needs to be operated in the harsh environment also. either high temperature mode, high pressure mode, okay, like that. It needs to be support all the harsh conditions. Next, distributed. So I designed some camera. This camera may be used in the mobile phone or CC camera or wherever it is required, like this distribution. Individual embedded systems are used to design the larger embedded systems. Example, ATM machine. ATM machine contains scanner, scan also one of the embedded system, and internally validating the card, that is also embedded system, or take the printout, that is also embedded system printouts, or counting devices, that is also embedded system. So individual embedded systems are combined to design the larger embedded system, like ATM machines or mobile phones. So like that, I need to design the distributed embedded systems. Next, small size. If I design the system with larger size, means it is not flexible to carry or to place the device in our device. Example, four-wheeler. In four-wheeler or automobile field, there are so many number of embedded systems. If it occupies more size, means there will no place to the passengers. Anti-lock braking system, hand lever or entertainment system, wiper control, vibration control, automatic temperature control, ignition control, whatever the device, door lock control. If I place all the device more size, means where the passenger will sit in the vehicle. Okay. So whatever the embedded system I designed here, that needs to be small size is better for easy to carry, for providing flexibility to the customer. Otherwise, as the number of embedded systems increases, the entire vehicle is occupied by these embedded systems. So there is no place for sitting the passengers. That's why most of them prefer the small size embedded systems, like mobile phones. In the olden days, the mobile phone used for voice calling only. If you are adding camera, means the size of the camera mobile phone is this much of size, means where we need to place in our pockets. Is it possible to keep it in the pockets? Not possible. So again we are providing gaming facility, browsing facility, more 108 megapixel camera or 200 megapixel camera. So this size will be more, means the overall system size increases. It is somewhat inflexible, not flexible. So we need to design the system as with a small size for providing the flexibility to the customers. Next, weight. Same matter. If the weight is more, means as the number of applications increases, the overall weight is increases. So customers is not interested to purchase the weighted devices. Lightweight device only they are preferring. If mobile weight is somewhat more, means it is somewhat inconvenience to carry the mobile phones or additional devices, additional books or whatever. Next, power consumption. It is also one of the important parameters. Why? Because most of the embedded systems are battery operated devices. If the power consumption is more, means the battery backup reduced. So battery backup reducing means again we need to charge. In some conditions while traveling, it is the charging facility may not be available. So After 5 hours or 6 hours usage of the device, the mobile charging will be 0. So, we are not using that. There is somewhat inconvenience. That's why we need to design the systems with low power consumable devices. As the power consumption reducing means battery backup increases. Okay. One more benefit is power consumption reducing means heat dissipation reduces. Heat dissipation reduces means heating of the device also reduces. Heating of the device reducing means there is not much that requirement of cooling fans. So power consumption is also one of the important characteristics. These are the different characteristics of the embedded systems. Application and domain specific means whatever the purpose we decide, we can use for that purpose only. It is not possible to alter that requirement. We cannot take printouts from the washing machine. We cannot play the music from the washing machine. Example. Next, reactive and real time. With respect to changes in the real time requirements, the response may be changes. That is reaction. That must be required. Real time means they have deadlines. Within the deadline, the task needs to be complete. Operates in the harsh environment. Means whatever the harsh environment, high pressure, high temperature, or high humidity, whatever the very low temperatures, means minus degrees temperature also, whatever the embedded system is designed, that needs to be worked. In that manner, we need to design the embedded systems. Distributed means the individual embedded systems are combined to design the larger embedded systems. Small size. We need to design the embedded system with small size devices, easy to carry or provide more flexibility, comfortability. Another is small weight. Small weight means easy to carry. That's also. Power consumption means to provide the battery backup, reduce the heat dissipation, avoiding the need of cooling fans. So these are the various characteristics of the embedded systems. Next, quality attributes of the embedded system means along with characteristics, we need to consider some of the parameters. Those are non-functional that needs to be addressed in the design of embedded systems. Quality attributes are the non-functional requirements that needs to be addressed in the design of embedded systems. So these are two types. Operational quality attributes. Operation is while operating the embedded systems. We are considering with some parameters. Attributes means parameters. Operation means while operating the device. Another one is non-operational quality attributes. Not operate. First, operational quality attributes means while using the embedded systems, what are the parameters we need to consider? First one is response. How much fast we are getting the response? Suppose any person comes in front of the vehicle, how much time it will take to control the vehicle movement? How much within that time? That is the response here. How much fastly the ABS will respond. Okay. Suppose I am entering into the shopping mall. How much fastly that open the door? It is not opening the door means What is the need of designing? Okay. How much fast it will provide the response. Throughput. In the unit amount of time, how many number of embedded systems are produced? Suppose in case of manufacturing plant, we are designing some device that produce the number of PCBs will be manufactured, or number of milk packets will be produced, number of some units of devices, either PCB devices or PCBs, or number of mobile phones will be manufactured, number of ATM cards will be produced, whatever the electronic gadgets or whatever the products we are designing here, that is required. Next, reliability means what is the possibility of getting the errors while using the device in some duration. Suppose I am purchasing China mobile phone. The lifetime of the mobile phone may be 2 years. After 2 years, may not be getting the same quality, same sound quality, same picture quality, or same battery backup, may not be get. So, how much reliability is providing by this embedded system? This quality. Frequently we are getting the errors, or frequently we are getting the issues in the device, means we will fulfill. So, we need to design as possible to avoid the issues or repairs we will get in the device while using that one. Maintainability. Suppose if any error occurred, how much time it will take to clear that error? Suppose some of the companies, Sony company, stop the manufacturing and services for Sony laptops. Suppose I purchased Sony laptop the previous time, I am using the same Sony company laptop, still if I get any issue, if the service is not available, means shall I prefer the purchase of next time, same product? Not interested. If they are not providing services, why I need to purchase? So the company is providing the maintainability. How much time will take to rectify the issue in that product? Next, security. Anybody capturing our information from our mobile phone? Is there any leakage in our mobile phone? Is provide that much of security for financial transactions or ATM card passwords, what are the details? Anybody getting that one from our mobile phone? Is there any internal leakage, data hacking? So that is security. That mobile, so we are thinking that Apple mobile phone is more secure when comparing with other mobile phones. Like that much of security is not possible to copy the data. Means unauthorized data, unauthorized copying. Next is safety. Suppose I am working in manufacturing plant. If it release any poisonous gases, if I feel swallow that one, means my health is damaged. After some conditions, maybe died. Or while operating a mobile phone, it generates some radiation. That radiation may affect my health. So that much of radiation is generated in the device, in the embedded systems. That much of poisonous gas are releasing in that one. Or if any leakage or any blast occurs, how much it will affect the person, customer? Is it safety to operate that, to utilize that device? So, we need to consider these parameters. Our mobile phone provide more safety, more security. We are providing more service. If any issue occur, more reliability. That mobile may be getting same quality after utilizing that much of period, either 5 years or 10 years. That much of. If you are purchasing iPhone, after 5 years or so, mostly provides same quality when comparing with China mobile phones. Same sound quality, picture quality, voice quality, like that. Same speed also. These are the operational quality attributes we need to consider while designing the embedded system. Next, non-operational quality attributes. Other than operation, we need to consider some of the parameters while designing the embedded systems. First one is test ability. During the designing the embedded system, we need to consider all these parameters. First one is testing ability. After designing, is it possible to test the design? That much of tools are available or not? Suppose I am established some of the company. My company designing some of the embedded systems. So at that time, I am easily getting the testing tools to test my design. Or is it difficult to get the testing tools to test my design? In some of the cases, trial versions are there. Some basic mobile phones or some basic designings require trial version sufficient. Some of the cases. Or if you want to get license, if it is free or it is somewhat more cost or average cost or low cost, we need to consider. Suppose I am designing mobile phone. My mobile phone I am using Qualcomm processor or MediaTek processor or ARM processor. So that company providing the testing tools with a reasonable cost or freely or low cost, average cost or more cost. I need to check. Our tools are available or not, first of all, instead of cost. It is not possible to testing this, right? I need to design. Use that one. I can go for another one. Product. So, shall I testing the product easily? Similarly, debug. Debug means functionality deviations, identifying the functionality deviations. Suppose I am designing some adder circuit. 1 plus 2 equal to 3 is the right answer. But I am getting 3.001 means some deviation is there. So shall I identify the debugging, the deviation easily or not? Is it difficult to identify the deviation? That much of tools are available in my design, in my products, whatever the products I choose it. 805, particular company, Intel company, or AMD company, or Texas Instruments company, they are providing the tools, debugging tools easily, or low cost or reasonable cost, or the tools are available or not. That we need to check before going to the design. Next, evolvability. Means, shall I use this one? Shall I extend? Suppose I am using 4G. In coming days, shall I extend the feature to 5G? Like that. Next, portability. Means, I am designing some application for particular processing element like 8086 or 8051. The same code shall I use for TMS 320C6713 processor. Why? Because again I am designing because nowadays the technology improves, advanced day by day. New processing elements are coming into the market. Every time I am designing from basic onwards means how much it will take. Development time increases. The development time increases means what is the need to design, because it takes much time to release a product in the market. Before my releasing, another competitor will release the product in the market. They will customers purchase that one only. The best example, while 4G launching, Jio introduced the 4G network in India. At that time, How many competitors or manufacturers providing the 4G handsets in the market? Whoever first release the 4G handsets in the market, customers are preferred to purchase that one only. They don't want to purchase the product again and again, and they are not investing that much of money in the purchasing of mobile phones. So, if the development time is more, means it takes some delay to release a product in the market. Before that, another competitor release a product into the market, and we are losing our margin. Some cases, we are not getting the investment amount also. That's why we need to check our design is able to testing easily or not. The tools are available or not. Easy to debug or not. Our design, embedded system design, easily debug or not. Or how much time it will take to test the product, debug the product, or if any new processing element is coming, the same design can use it for new processing element or not, new hardware or not. That needs to be checked. And time to prototype. So means development time. Within that time, is it possible to design the product? Within the time to prototype. And release the product in the market. That needs to be checked. If it takes much time, means before that another company will release the product into the market and they are getting the margin instead of myself. Next, per unit cost and revenue. So, after releasing the product to the market, what is the cost of the product? Is it reasonable cost or low cost or high cost? iPhone is the more cost when comparing with China mobile phones. So, is it possible to provide my product with a reasonable cost or not? So, initially, until we are getting the investment amount, we are giving some average cost. Later onwards, we are reducing the cost by giving some offers like iPhone. And we are getting maximum margin or not. So, these are the parameters we need to consider while designing the embedded system. For this topic, I refer the textbook is Introduction to Embedded Systems by Shibu KV. The publisher is Tata Mehra. Second edition. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.